This is a loop topology. And how do we prevent these? Well, we use a protocol called spanning tree protocol, and there are many variations. We have CST, we have PVST, we have MST, and many others. Sometimes we call it MSTP as well. Now, this is a loop prevention mechanism that allows us to prevent broadcast storm and, of course, prevent loops. How it works is this switches, switch 1, 2, and 3. This is supposed to be switch 3. Hold on, let me correct. There. Alright, so these 3 switches will send what we called BPDU, or Bridge Protocol Data Unit. So all of these switches will send BPDU, and this switches, switch 2 and switch 3, will also exchange or send BPDU to each other. Now, what is BPDU? It stands for Bridge Protocol Data Unit. And this includes, this is a layer 2 information that includes priority value and MAC address. And what is these two values for? Now, we need to elect what we call the root bridge. Okay, the root bridge is consider root bridge as the center switch. And how is this root bridge being elected? As you can see, we are sending BPDUs, switches here in our topology. And based on those information, which is a priority value, if a switch has, automatically it will become the root bridge. But if the priority value are all the same value, it will go, or it will look for the lowest MAC address. So let's just say the root bridge is switch 1. Okay, again, this is the center switch. Now, what will happen is all of its ports will become forwarding, okay, or designated role. And I will just add here, the root bridge is the center switch. And this is elected based on BPDUs. Based on BPDUs. There. Okay, so if the switch 1 is the root bridge, how about switch 2 and switch 3? Well, it depends, but we're not going to talk about that in more detail. What will happen is one of these ports will become the blocking port, and that's how it prevents loops. So what I'm gonna do is I will put this interface of switch 3 in blocking mode, assuming that switch 3 has the lowest MAC address, okay, because he is the least among all of these three switches, least in priority. Now, what will happen here is as PCA and PCB and server C sends traffic to each other, the traffic flow will be like this. PCA, if it sends traffic to PCB, it sends from switch 1 to switch 2. How about from PCA to server C? Okay, switch 1 and switch 3 are directly connected to each other, so no problem. How about PCB and server C? Okay, so in this case, PCB will only be able to communicate to server C via the root bridge, switch 1, and to the destination, switch 3. Because again, this port is blocked. Alright, now, what we're gonna do next is we're going to add a rogue switch. And a rogue switch can be a PC with attack tools. Okay, so what I'm gonna do is this attacker. Okay, this is an attacker. It will connect on all switches. Switch 1, switch 2, and switch 3. There. Okay, and since this is a switch, it's now a switch, and this interface, it's all trunk ports, so it can carry many different VLANs. So it is now a switch, so then it will sense BPDU. Now, if it sends BPDU, since it is attacker, it will use a higher value BPDU. So, lower priority, higher priority value, and also a lower MAC address. Okay, and it should be bogus, like a spoof MAC address. Now, if it sends BPDU, okay, its aim to be or to become the root bridge. So you will say, hey, I have the lower priority value and the lowest MAC address. It will now become the root bridge. So what will happen is switch 1 will no longer be the root bridge. This guy here is the new root bridge. Okay? If this is now the new root bridge, what will happen here is all of its interface are forwarding state. How about the others, the other switches? Well, in this case, switch 1 connecting to switch 2, assuming switch 2 has a has a higher MAC address value, this will be blocked. Okay, and for switch 3 and switch 1, assuming switch 3 has a higher MAC address value, this interface will be blocked. Okay, and this is our new topology now. Now, let's test. With this state, switch 1, switch 2, switch 3, and our hacker, our attacker that is pretending to be a switch, what will be the route from PCA to PCB? PCA is about to send traffic to PCB. So since this is blocked, it will now send it via the attacker, which is now a switch, our root bridge, and then it will forward it to PCB. Now, if PCB wants to send traffic to server C, again, this is blocked, this interface is blocked, so it will send it not to switch 1 anymore, but to the hacker switch, the new root bridge. How about server A, PCA to server C? So this is our PCA. If it sends traffic to server C, it's not directly connected switches anymore. It will be, again, via the root bridge, the attacker, and then it will send it to switch 3, destined to server C. As you can see, all traffic from PCA and PCB to server C will traverse to the hacker PC or to the hacker switch, and the attacker can sniff all of this traffic. Now, what we're gonna do is we're gonna protect this type of topology, this environment, and to do that, we're gonna introduce the security. We're gonna introduce these two features. This is called STP BPDU filter and STP BPDU guard. Now, both is fine. It's a matter of which one is your preference. So let me just clean here. Okay, and okay, so here's what we're gonna do. I'm gonna disconnect first this link. Okay, and I'm gonna also erase this. I'm also gonna erase this, and I'm gonna also, actually, I'll keep the blocking port on switch 3. So there you go, and I will also erase this. Okay, so this is our working topology. Switch 1 is the root bridge, and the switch 3 interface going to switch 2 is in blocking port. Now, if this attacker connects to all 3 switches, switch 1, switch 2, and switch 3, if we enable BPDU filter as the attacker sends BPDU, and this BPDU is a powerful BPDU with a lower priority value and a lower MAC address, what will happen is, so it's sending BPDUs now, right? BPDU. What will happen is, okay, before that, maybe you're thinking, where should we apply or enable BPDU filter? Okay, I forgot to add this. BPDU filter is enabled on the non-active ports, meaning this port these ports where the attacker is connected to, these are, or these were non-active, these were inactive, these are just open ports. So all of the open ports, all of these open ports, this is where you enable BPDU filter or BPDU guard. Okay, so let me highlight this port, this port, and this port. Okay, and any other open ports or inactive ports. This is where you configure BPDU filter or BPDU guards. Okay, so let's continue. So we already have interface with BPDU filter enabled, and as the attacker sends BPDU here and BPDU here, what will happen is, as soon as BPDU received by this interface and this interface, it will just drop it. So basically, BPDU filter is just about filtering BPDU on certain ports. Okay, so basically it filters and drops BPDUs. Now, BPDU guard is a little different, because if you enable BPDU guard and this attacker starts sending BPDU on these interfaces, it will not exactly filter or drop BPDUs, but what it will do is it will disable this interface due to a violation, because it's like a policy that no BPDUs should be sent to this interface. So if BPDU is received, oh, it's violating policy, therefore we're gonna block these interfaces. So in this case, this attacker is not so successful in becoming a root breach.